Hello friends, I have designed microcontroller based single phase induction motor direction controller. So let me show the process first. See, these are the inputs. So by pressing this push button, the motor will rotate in clockwise direction. By pressing this button, motor will rotate in anti-clockwise direction. And this button is to stop the motor. So let's start the motor in clockwise direction. See, it is rotating in clockwise direction. The motor is stopped. It's rotating in anti-clockwise direction. These are the two LEDs to indicate the direction. Red LED indicates the anti-clockwise direction of the motor. The green LED indicates the clockwise direction of the motor. See. Oh, it is. This is for anti-clockwise. Wait. Clockwise. Stop. Anti-clockwise. Stop. Clockwise. Anti-clockwise. Clockwise. Anti-clockwise. Clockwise. Anti-clockwise. Stop. Interesting, right? So see, these are the elements which I've used here. See, I've used Arduino Nano microcontroller, 3 push buttons as an input, 2 transistors to drive these 2 relays, okay, 4 resistors, these 2 resistors to limit the flow of current to the LEDs, and these 2 resistors to limit the current to the base of the transistors, to limit the base current, okay. And these are the 2 diodes which basically bypasses the high voltage spikes which is generated by the relay coil, okay. So and see here I'm using a triac module basically to reduce the terminal voltage of this induction motor, so as to clearly see. So by reducing the voltage, the speed reduces, so that will make the direction controller more visible, means the change in direction will be more visible. That's why I have used that track module. And this motor, see, single phase induction motor. So just focus here. This is the main module, main drive, main controller. This is the main direction controller. So focus here. So this is basically the overall hardware view, okay. See, it's pretty complicated, right? But it is very simple, and the scenario here is very much complicated, the circuit connections here, but in the circuit diagram it will be more clear. So let's switch to the circuit diagram. Here it is. See, very neat and clean, very easy to understand. See, I need to control the direction of this induction motor. So I need to know how the direction change takes place. So there are 3 terminals from the motor, okay. There are 3 terminals from the motor. What I've done, I've connected live wire to one of the terminal, okay, and the rest of the 2 terminal is connected across the, and capacitor is connected across these 2 terminals, okay. So how I will change the direction? The direction is changed by changing the connection of neutral wire along these 2 terminals. Means what? If I connect the neutral wire to this terminal of the motor will rotate in, say, clockwise direction. And if I connect the neutral wire in the middle terminal of the motor will rotate in anti-clockwise direction. This is the fundamental concept, and this neutral and live wire can be interchanged. means the neutral can become live and live can become neutral. There nothing yeah, what I will say means no difference will be made here. Okay, because it is AC signal. Okay, there is no matter of polarity, right? So this is the basic fundamental concept. So this is basically the manual process. So this manual process means physically you are changing the connection to change the direction. This is not feasible, right? So what I've done to fix this issue, I have just installed relays. Means to automate the process, to automate the direction control, I've used these relay contacts I've used. So what will happen by these, by changing the contacts, it will automatically change the connections of the neutral point. Okay, see here, I've connected the connection in NO contact of the relay. So when the coil gets energized, the NO becomes NC and the connection is made and the process takes place. Okay, the process happens. If this relay activates, the NO becomes NC, and say motor will rotate in clockwise direction. And if this relay gets activated, the NC becomes the NO becomes NC, and say motor will rotate now in anti-clockwise direction, in either direction, say. So this is the basic fundamental concept. And see here, to drive these relays, what I've done, I've used two transistors. So these two transistors is basically driving these two relays. And see, two diodes I have connected across the coil of the relay to protect the transistor. Means what? This diodes will bypass the high voltage spikes of this coil. Okay, see here, and these relay is rated 12 volt, means the coils are rated rated voltage of the coil is 12 volts, so I have to give the supply of 12 volts, so I have given here. Okay, and see, two LEDs are there for indication, and three push buttons as an input, and the controller. See, from the controller, see the pins, see pins 3, 4 and 5 I've connected push buttons, that is connected to the ground, zero potential. Pin 8 and 9 is connected to the base of the transistors via current limiting resistors, and pin 10 and 11 is connected to the LEDs, indicating LEDs, that indicates the change in direction via current limiting resistors. Okay, so this is the whole circuit diagram. Now I'll say the logic. What is the logic? What I've done, I have identified how the change in direction takes place. I've installed the relays, I've provided the connection, I've connected whole thing, all means a hardware part I've done. Now I have to implement logic, means logical part I have to make. So to that I have to create programming, I have to do programming. So at first I will say the logic in brief. So what is the logic? If you press push button 1, what will happen? It will connect to ground. So if push button 1 connects to ground, logic high signal will flow from pin 8, and logic high signal will flow from pin 8 and pin 10. So the transistor 1 will be activated, and accordingly the relay will be activated. First relay will be activated, and simultaneously this LED will also be activated, and that will rotate the motor in clockwise direction. Okay, and if pin 2 is pressed, logic high will flow from pin 9, and logic low will flow from 8. Means just opposite case. Means now the first relay will be turned off, the second relay will be turned on. Means this transistor is activated and this LED is activated, and the motor will rotate in anti-clockwise direction. Very simple concept, very simple logic. So now we will see the programming, the code. Okay, so let's see the code. So here is the code. It's very simple. See here, what I have done, I have declared integer type variables. What are the variables? D1, D2, LED1, LED2, button 1, button 2, button 3. D1, D2 for direction, LED1, LED2 for the indicating LEDs, and these are the for buttons, and I have assigned pins right here. Okay. See, in the setup function I have basically declared these pins as outputs. Means these pins I'm taking output from this pins I have declared here, and the button pins I am giving input, providing inputs I have to declare, right? So input. In the loop function, the basic logic I have implemented here. Okay, means everything is rotating here in the loop function. So there are certain conditions I have made. What are the conditions? If button 1 is connected to ground, is 0, is low, if the controller reads 0 signal from button 1, then this process will be performed. What is the process? Digital write, means it will write. Okay, means it will provide output. What is the output? D1. D1 means pin 8. Pin 8 will be high. Pin 9, D2 is pin 9. Pin 9 will be low. LED 1 means pin 10. Pin 10 will be high. LED 2 means pin 11 will be low. Okay, see here. See here. If this push button is pressed, pin 8 will be high, pin 9 will be low, pin 10 will be high, pin 11 will be low. Means first relay is activated and first LED is activated. And if this relay is activated, the motor will run in clockwise direction. Say clockwise direction. Okay, so this is the concept. See, in the second condition, if the button 2 is reading 0 signal, what will happen? Just opposite case. D1 is 0, D2 is 1, LED 1 is low, LED 2 is high. 1 means high, 0 means low. Simple case. Okay, means what? Now this relay will be turned off and this LED will be turned off, and this relay will be turned on and this LED will be turned on, and the motor will rotate in anti-clockwise direction. See, very easy logic, very simple. And finally, in third condition, see, in third condition, button 3 is when button 3 reads 0 signal, is equal to 0 signal, and the whole process turns off. Means what? D1 is low, D2 is low, LED 1 is low, LED 2 is low. Means see, when this push button is pressed, connects to 0, the third push button, whole process, see here, all the pins go low and the process turns off, the motor turns off. As simple as that. Okay, so finally I'm showing once again the process. See, rotating in, motor is rotating in clockwise direction. Stop, motor is stop, anti-clockwise direction. Stop, clockwise direction. So that's it. I hope you all enjoyed this video. I hope you all have learned something new in this video. So I hope you all like this video. then don't forget to like, share and subscribe. And stay tuned with me. Thank you. Have a nice day. Bye.